Hello, here I'm going to present my project on CSCI 89, the deep learning. The project title is Facial Recognition with Images of Nepalese Celebrities. And here I'm going to compare how the 6 pretend models I built will work and find out what is the problem and how I can solve it. And this slide summarizes the overall process of facial recognition. Started with images of celebrities, and then they are subjected to neural transform, and I use 4 style images for neural transformation. After neural transformation, I bunched them together with the original images, and this package of trained uh, package of images for the training data are subjected to modeling, and when they are fed to the model, the models are trained with those images and the trained model is obtained. When the trained model is obtained, I test it with the testing images which are not exposed to the model before and see how the models recognize those images. To do this facial recognition, my images, I have to split them into different proportions, into different sets, like train set, valid set, and test set. I split the data into 70% of my data into train set, about 15% to the validation set, and 15% to the test set. And I wrote a code to do this. And after doing the splitting, I inspected all the split data, train data. I also inspect the full data set, test data set, whether they are properly split or not. And here, this is a full data set. The full data set contains 1612 images, and there are 49 celebrities images, and they have different number of images, and their images have different size. And I'm also looking at what is the maximum size of the images and what is the minimum size per persons and so forth. And this is a method to use how these dataset are split into train, validation, and test. After splitting, I also inspected whether the splitting occurs correctly or not. I inspected the train dataset and it is splitted about 70%. So there are 1100 images in the train dataset. I similarly inspected validation dataset as well as test dataset. After splitting the data, I have 3 sets of data. One is training data, another is validation data, and third is test data. I'm using training data as well as validation data to train my model. Use the train data for training and validation data for validation, and testing data are not exposed to the models before training. Since I have the small number of training data, since the only 1600 images are not good for doing the training of this kind of work. So I decided to use neural transfer, neural style transfer. When I use the neural transfer, especially I use 4 style images to do neural transfer, so that I can increase the number of training images to about 5 times. 4 from the production of these 4 star images, and the 1 by the original image, so that the total of 5 times images. So this shows how the images changes after neural transfer. In each row of the images, the first image is the original image, and 4 images are produced by style transform using the 4 styles before. And this is another person. The images changes how the style are applied. I also applied another method which is called data augmentation. When the data set is very small, there is always a chance of overfitting. To mitigate the chance of overfitting, we have to do something. So this is one of the method which is called augmentation. This is artificially increasing the volume of the images, trained images. Here we are doing rotation. By rotating the images, the image angle will change. So by shifting the image, and there is you shear the image, zoom the image, and horizontal shift. By doing this, we can input the diversity in the images so that there is a reduction in overfitting during training. I also use the dropouts and batch normalization and L2 regularization to also mitigate the process of overfitting. Compiled as shown here, and then after compiling the model has to be trained with the training data. The fit method is used to train the model. And during the model training, I also use checking checkpoint callback, early stopping callback, and early and reduction of in learning rate callback. So this also helps in mitigating the problem of overfitting. And the data are fitted, and the history of the training is saved in the history parameter. So let's say this is NST. So this is the model performance for the models without NST. And see, this is the VGG method where the model performance without NST is, if you see the model accuracy is about 25%. And the bottom one is the same model with NST, which has about 30% validation accuracy. This indicates that the NST improves the performance by about 5%. And this is another method. You see the top figure is without NST and bottom figure is with NST. So both has very low performance, and validation accuracy is as low as 5% in both cases. And this is the third one. This is also very bad, and the validation accuracy is as low as 5% irrespective of whether there is NST or not. And this is another method. See, here also there is no any good performance. So the validation performance is still like as low as 3%. And this is the next method. Here also the performance is very poor, like in the 2 or 3%. And this is another one. Here also this is very bad.